I introduced the built-in linked list class to us, right? And then we talked about, I remember I was quizzing you whether this was going to print out cat, dog, or elephant, or was it going to print out a memory address? And I think that was it State Farm that finally told us about the two-string method? Yeah. So even generic objects. Oh, wait, hold on. I asked a question in the class. Didn't I? Didn't I end class with something like, is LeBron James in costume still LeBron James? Didn't I say something like that?
I think you said in drag.
In drag. Yeah. LeBron James. Well, a costume. Drag is a type of costume.
Yeah, being specific about it.
Okay, fine. So is LeBron James in drag? Is he still LeBron James? Can he still dunk? Sure he can. Right? He's LeBron James. Even though he didn't look like LeBron James, he still was LeBron James. So when we get one of these generic objects out of our linked list, they come out of the linked list as generic objects. They're in costume, but they still are strings. So when the println method calls the toString method on that generic object, it's going to be passing the toString method to whatever that guy actually is. He'll try to execute his toString method. If he can't, he'll pass the buck up the stack. Okay? So this guy comes out as a generic object. He's in costume, but he actually is a string. So when println calls that particular object's toString method, it's the strings version of toString that gets called, which knows how to display a string. As opposed to, did we actually fill one up with like random objects or something? Do we actually go that far, or we stop kind of here? Okay, so let me go ahead. Yeah, we'll do this. Instead of filling it up with strings, we'll fill it up with instances of the random class. We're going to have to import java.util here. Everybody see the screen fine, or you want to light off? Apparently the patriarch wants to light off. Well, you missed a good pancake breakfast at church on you bailed.
I know.
They had strawberries and whipped cream, and kids running around screaming. The whole.
Sunday brunch at Charcoal Grill.
Yep, you have to pay for that?
Yeah, pay for that. That was unfortunate.
Yeah, there was a free brunch at church. Should have invited your brother to church.
We should have.
Yeah.
If I had known it was free breakfast prior.
They've been announcing it for like weeks.
Yeah, never mind.
Yeah, it wasn't like a last minute thing. This was like a
Really, I don't listen.
couple of months ago they might have made the decision. Said save the date, Palm Sunday, pancake breakfast. They had sausage too. They had mimosas. No, they don't have mimosas at church. Get your head out of the gutter. Good Lutherans do you think they are?
Do they have bacon though?
No bacon. Yeah, that was upsetting, but the sausage was actually really good. All right, so we're going to fill up this generic linked list with a bunch of random objects now. All right, and we're going to print those guys out. Now it's going to print out a bunch of memory addresses. Why? This guy came out as a generic object. I'll remind you about that. ll.get, notice this guy returns an object here. Okay? Not a random, but an object, a generic object. When I say get me whatever lives at bucket I in that linked list, it's going to come out as a disguised random object. But regardless of whether he looks like an object or he looks like a random, println's going to call this particular guy's toString method. Random does not implement a toString method. So it inherited the toString method that came from object, his parent. So that's why this guy looks like a crazy memory address. Make sense? Now, the nice thing with linked lists, did we talk about generics last time? Okay, nice thing about linked lists in Java, this is kind of the problem with linked lists historically, is that when we build a linked list, we can store things in there generically, and then when we pull them out, we have to kind of cast them back to what they actually are. Linked list, or Java supports something called generics. The linked list class in Java supports generics. So we're going to store an array or a linked list of strings. This is going to be a new linked list of strings. So this is a special syntax. This is the syntax for generics. And we'll go ahead and put some strings in our linked list. Now let me just show you this. When I say ll.add, notice now it's expecting a string as a parameter, not a generic object like it did before. So by using the generics syntax up here, it's letting Java know that this particular linked list is built for holding string objects, not generic objects. So this guy's expecting a string. All right. Similarly, when we retrieve the object, notice that it's coming out as a string. Okay? So using this special syntax here, we're saying I'm building a linked list for holding strings. Similarly, this is similar to building an array building an array that holds a string or holds an int or holds a char, that kind of stuff. Okay? So we can build linked lists for holding specific types of objects. Now, we could put in strings into a generic linked list. We've already done that. We put random objects into a generic linked list. Now we're building this linked list specifically for holding strings. The advantage of that is when we take them out of the linked list, they come out as strings. Which then keeps us from having to typecast them back to whatever they actually are and work with them that way. Okay? So this is a convenience rather than a requirement. All right, does that make sense? All right, so this is called generics, and this is the syntax for supporting generics. So now we have access to this power tool built into the Java language called linked list, which supports all the crap that we've implemented in linked lists. And specifically, we can build linked lists of any type that we can create a variable of very easily. Okay? So, big power tool there. Questions about that? Okay, now I think last class we were talking about this cave crawler demmy thingy majiggy thingy, right? Okay. So we started talking about this concept of an n-ary tree. An n-ary tree, we think we drew a little picture, might look like this, where we have a root node. So all trees start off with a root node, and then each node has 0 or more children in an n-ary tree. So this node has 2 children, this node has 2 children, this node has 1 child, this node has 2 children, this node has no children, so on and so this node has no children. Make sense? So it creates a tree structure. So it's still a linked data structure. That is, this node is linked to this node and as well as this node. That's where it differs. It's not a linearly linked data structure. It's a tree-based data structure where each node is linked to multiple other nodes, potentially multiple other nodes. Okay? But these are still linked, so it's still memory efficient. These nodes are not necessarily contiguous in memory. This guy has his own memory address, this guy has his own memory address, this guy has his own memory address. They live somewhere in memory, and we have a pointer that binds them together. Make sense? Okay. So what we want to do is our little example / awesome game. It actually kind of is an awesome game, I think. Is we want to create this cave. And our cave is actually going to be an n-ary tree, similar to our Towers of Hanoi assignment, where each tower was a stack, right? The game, Towers of Hanoi, was a collection of 3 towers, and the towers were a stack for holding disk objects. So a cave is going to be our n-ary tree, where each node in our tree is a room in the cave, okay? So this whole thing here is a cave, or a tree. This is a room, this is a room, this is a room, so each node is a room. Okay? So, a cave has a single root node of type room. A room has a name, it has a collection of exits. How many exits does each room have? Well, maybe in our game we decided it has 0, 1, or 2 exits. But since we don't know exactly how many exits it's going to have, since it's 0, 1, or 2, we're probably going to make this a linked list of rooms. Does that make sense? And a room might have treasure in it. Well, speaking of treasure, have any of you ever done anything with Bitcoin mining?
Yeah, but it's not worth it.
No, it's just interesting. Well, it can be worth it. You just have to not be the one paying for the electricity, and you have to have ridiculous, and you have to have, you have to also have ridiculous amounts of processing power through the ASIC devices and stuff like that.
Or you're doing it through something illegal like a botnet.
Well, but even then, you're probably not going to generate enough hashes to make it worth it. But from a hobbyist perspective, mining Bitcoins is really cool. You could set up a computer in 20 minutes, and it goes out there. And so kind of the high-level thing of this, I've been looking into this. It's just fascinating to me. Everybody in here is familiar with Bitcoins, right? At least at the high level buzzword, it's fictitious currency, right?
Cryptocurrency.
No, fictitious currency. Okay, it's currency that doesn't exist. But people are using it for trading stuff. Now, the proponents of Bitcoin are all about that, okay, well, there isn't a central bank, blah, blah, blah. So US dollars, who prints the money? The US government. Well, the value of that money is based on how much cash the government prints, right? So the Bitcoin proponents don't like the fact that, the government's in charge of the money. So with Bitcoins, the internet is in charge of the money. There isn't a central authority for the money. Well, somebody needs to handle all these transactions for Bitcoin. So when somebody buys a pair of shoes with Bitcoins, there needs to be some sort of computing power behind the scenes for managing that transaction securely. So that's where this Bitcoin mining thing comes in. So you have a bunch of computers that are all handling transaction processing. And as you're devoting your time to it, you're kind of playing this massive game of solving these problems where you're mining, you're being paid for your help in this endeavor. You're being paid in tiny, 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 tiny fractions of a Bitcoin that look cool at first. And then you realize when you do the math, it was going to take you like 7,000 days to get one Bitcoin or something like that, something ridiculous. But it's still entertaining to say, okay, well, I now am an owner of Bitcoins. And one day you can own something like, 0.11 millionth of a Bitcoin or something like that in one day. So you technically could be an owner of a Bitcoin by later today. A fraction of a Bitcoin, but a Bitcoin owner nonetheless. And then you learn about the stuff like the Bitcoin wallets and then you have to secure your data for your Bitcoin wallet, because if you lose your wallet, if you lose the pointer to your wallet, your Bitcoins are gone. Nobody else has them. They're just gone. It's like automatic garbage collection with a pointer here, right? If we lose our link to this guy, he's gone. Well, this might be your wallet. It's just, I don't know, it's just fascinating to me. Time will tell whether Bitcoins actually become something legit. It's actually supported in lots of sci-fi books, like money is called credits. Now it's all digital. There's no actual paper money. I don't know, just fascinating. Chances are we'll end up screwing it up somehow, but still very fascinating. That's what. Huh?
We already have.
Screwed up Bitcoins?
Yeah. Well, they used to be worth like 1,000 each.
Well, that's not screwing them up. That's just normal economy.
Well, the reason why they dipped so much? The Silk Road online got taken down by the feds, and Bitcoin plummeted to about $800.
Yeah, that's fine. I mean, we've had stock market crashes before. The U.S. dollar still rebounds.
Yeah,
I mean, it's not.
It was so reliant on the black market that's why the price was as high as it was.
Well, fine. So now it's maybe more in line with where it should be. Realistically, it's probably not in line where it should be. It's probably still too high.
Probably.
But it's still so rare. That's why, it's kind of like, going out and mining for gold. Gold is expensive, even though it's worth a lot less now than it was a couple years ago. But gold's expensive because it's rare. Bitcoins are expensive because it's rare. U.S. dollars, they're cheap. Why? Because we just print more. They're not very rare, right? You can just walk around and find you dollars laying all over the place, right? Inside people's wallets and purses and. I mean, they're just all over the place. I bet you that if we did a poll in here, there'd be a couple of US dollars just laying around this room. All of a sudden, I like turn a switch, like some gas starts leaking into the room. So every one of our rooms may, in fact, have a treasure. Perhaps that treasure will be a Bitcoin.
I thought you were going to say that every one of the rooms have gas in them.
Gas and potentially a wood chipper. Beware. Wood chippers steal your coin. You start bleeding out. Actually, our treasure is going to be Bitcoin. There we go. I really like that one crazy guy that had like $14 million equivalent in Bitcoins. He decided to actually have them minted. So he turned a fictitious currency into a real currency. But the amount of money he spent having them minted, he had them minted in pure gold. And that's just being like a crazy rich person, right? It's like, okay, I have $14 million in fake currency. So what I'm going to do is I'm going to turn it into real fake currency. I'm going to spend a bunch of that $14 million creating the real fake currency. I think he ended up being a drug dealer or something like that. And they came and well, no, they came and raided his house and that's how they found out that he had minted his Bitcoins. Hey, that's the best defense that he's going to have in court. Like, look, I'm crazy. I minted Bitcoins. I bought into a fictitious currency and decided to make it real. All right. So every one of our rooms might have a Bitcoin in it. For our starting point, we might say there's a 50% chance that there's a Bitcoin in the room. That's our treasure. That's right. It is a lot of money. You can make bank with this, right? Okay. So a room has a name. I don't know why it has a name. We're just going to say it has a name. It has a collection of exits. 0. Here we're going to say max of 3 exits. So exits would be exit 0, exit 1, exit 2 for a room that has max. So we're just going to do it with numbers. That way when we have our interface for asking us which exit do you want to take, you put in a 0, a 1, or a 2, that kind of thing. Okay? So that's what a room will be. A cave will start off as a single room, and it will spawn, that single room will randomly decide how many exits there are, and it will spawn off new rooms. Each of those rooms will decide how many exits they have. It will spawn off more rooms. So we actually have almost like it's recursive-esque. A recursive-esque way where a cave grows on its own. Okay? So, if we go ahead and start writing this, we'll go into Eclipse. Let's get rid of all this crap. We're going to start off by creating a room. So we're going to create a new class. This guy's going to be called a room. And a room is going to have a private string name, the name of the room. Okay. And then it's going to have a private linked list of rooms called the exits. And then it's going to have a private Boolean has Bitcoin. Bitcoin. Okay? So now we need to write the constructor for room, public room. We're going to have it taking no parameters right now. We're going to set the name to always be a room for right now. Very inventive. Okay? So the name is a room. The exits will be a new linked list of rooms. Now we need to import java.util linked list. There's that guy right there. There's our exits. Okay, now we need to decide, do we have a Bitcoin in the room? And we also need to decide how many exits do we have. Okay, so what we're going to do is we're going to create an instance of random. For generating a random number, we'll have to import java.util.random. Then we're going to say this dot has Bitcoin is equal to r dot next Boolean. That's something we haven't used before. That just gives us a random true or false. So basically a basically a 50% chance of having a Bitcoin or not. 50% being as good as this pseudo-random number generator is. Okay, so that's our has Bitcoin. Now we need to determine how many exits we're going to have. Int num exits. Now we can have 0, 1, or 2. Well, we can have 0, 1, 2, or 3 exits. Okay? So num exits is going to be r dot nextInt, and we're going to call the version of nextInt on 4. That should actually on 3.
Plus 1.
No, on 4. This is what we want. This is going to give us a number between 0 and 3 inclusive. Okay? So r.nextInt is going to give us a random number between 0 and 3. Then we're going to say for int I is equal to 0, I is less than num exits, I plus plus. So we're going to create a loop for the number of exits we should be creating. And then what are we going to do? We're going to say this dot the exits dot add, and this guy's expecting a room, we're going to add a new room. Okay? Now, just so we can see how the interestingness of this, we're going to do a little system.println room created. Every single time we call the room constructor, we're going to spit out to the screen room created. This is our kind of our fake recursion right here. That is, every single room has between 0 and 3 exits. Well, that means that every single room has the ability to give birth to up to 3 new rooms. And each of those rooms has the ability to give birth to up to 3 new rooms. So randomly, our cave is going to grow here. And every single time we create a room, we're going to see room created spit out to the screen. Okay? So for right now, this is all room is. Now we need to create our cave. What did we decide a cave is? We decided a cave is a root node, a room. Simple enough.
There's way too many rooms there.
So we're going to create a cave object. Let me respond to this real quick. Okay. So a cave is going to have a private room called the entrance. That's the entrance to the cave. Every cave has a first room. Okay, that's the root node of our tree, if you will. We'll create our constructor. And we'll say the entrance is equal to a new room. So that's all of our cave right now. And that's all of room right now. Now when we create an instance of cave, a cave will generate one room, which will then generate up to 3 other rooms, each of which will generate up to 3 other rooms, each of which will generate up to 3 other rooms. So they're going to be reproducing like, what do they say, like rabbits? Okay? So we'll go ahead, inside of driver, we'll create a cave. A cave is equal to new cave. The output here, how'd your test go?
That old Japanese custom of stabbing oneself in the stomach with their own sword sounded appealing by the last question.
Oh, so good.
Yeah.
Okay, so when we create our cave, because every single time we create a room, we should see printed to the screen room created, there's a decent chance we're going to see a whole bunch of room createds. Or if we rolled some bad luck, we might only see one room created, right? So we'll go ahead and run this. We only created 2 rooms in this particular case. Bad luck. Let's run it again. What the heck happened there?
Broke too much memory. Probably.
Stack Overflow.
Yeah, way too many.
It's actually the first time that's happened.
First try.
That's just from having 3 exits?
A 25% chance to drop a room. You don't have a limit, so it's going to be.
Well, you'd hope it eventually reaches.
The further it goes, the less likely it is to drop. Because you have a 25% chance to only drop a room instead of to make.
Let's reduce our number of rooms down to 3. So that would be 0 to 2. I mean, we could fix it by just expanding the total amount of stack space for Java, but I'm just surprised that we ran out of space. Okay, so perhaps 3 rooms was too many. So we have 2 exits. You can have 0 exits, 1 exit, or 2 exits. Okay, so that's what we're going to do here. So we see that we're getting a whole bunch of rooms created. Potentially, right? Okay. Now, I want to somehow keep track of the number of rooms that are created. That is, every single time a room is created, I want to mark that statistic down somewhere. How do I do that? How would you go about problem solving that? It's a very interesting question, actually. Go ahead.
Create a field, and every time a room is created, increment that by 1.
Who has the field? Okay, so every room knows about the number of rooms created. We don't even need a field. Doesn't the exits dot count or the exits dot size tell us the how many rooms that room created? Okay, but at the end, I want to print out total number of rooms.
You have to store it outside of the room object.
Okay, so we're going to have to tally this outside of the room object somehow. Right now, we're printing out room created for every room that's created. I want to count those somehow. Okay, so you want to store it outside of it. Okay, how would you store it?
I don't know. You could use like a getter and setter.
For who?
You could create a class, or I don't know, use one that we already have. I don't know, but
Okay, so maybe we create a statistics class. Let's go down that route. So we create a statistics class, and the statistics class keeps track of the number of rooms that were created.
all right.
Okay, how would you use it? So here, let's go and let's write that real quick. By the way, I'm about to trick all of you. Call this guy stats. Okay, here's our stats class. Okay, and what do you want to store a field that's what, num rooms?
Sure.
Okay, so int num rooms like that.
Okay.
Then you want to write a constructor for this guy. And start this dot num rooms off at 0.
Well, you're gonna. Well,
You want to have a way of adding a room?
oh, I suppose, yeah.
As you were talking about getters and setters, right?
Yeah.
Okay.
probably build one of those still to use that, wouldn't we?
Oh yeah, you definitely would. So then we'll say public int get numRooms. This guy's going to return this dot numRooms. Okay, so there's our stats class in its current state. Okay, so we can build a stat object which starts off with numRooms as 0. Then every single time we create a room, we will increment numRooms. Every single time, then we can ask it at the end, how many rooms did we create? Okay? How are we going to use this guy? Well, inside Cave, you want to create a stats object. Like that.
Not gonna work though, because that's not in, well, because we can't really make it in either, and that's kind of where it would need to be.
Well, couldn't we pass it to the rooms as a parameter?
I think so, maybe.
Well, why wouldn't we be able to?
I mean, yes, we can pass it as a parameter.
So I can tell rooms that we need the constructor for rooms takes a stats object. And every single time a room is created, we can say the stats dot add room. And then inside Cave, when we create the room, we'll pass the stats to it. So we're just passing that pointer around, right? And then ultimately, we'll do system.out.println the stats.get numRooms. That should print out the number of rooms we have, right? Gotta save that for this to be fixed. Okay.
You
Sorry.
gotta add the stats into the other,
Have to who?
in the recursion in the room.
Oh, thank you. So every single time we create a new room, we're going to pass the stats. In the end, we created 4 rooms that time, 25 rooms, 11 rooms, 41 rooms, so on and so forth. Why is this a bad way of doing this?
It'd be better to use like static context.
Oh, I didn't trick you. Thought I was going to trick you, but I didn't trick you. Tell me about static context. What's the difference between static context and non-static context?
Well, with this, we have to keep calling it with an instance of whatever object we created it, that like placeholder in.
By the way, anybody who's not paying attention right now, there's a concept that's being discussed right now that's extremely important.
Whereas if we use static context, now we can just call it by that actual class name instead.
Okay? So Tim, what's the difference between static context and non-static context?
Static context is when it comes to a method or just anything.
This is in general.
Static is called by the name of the class.
Okay. So in this case, what would the difference be? Right now I'm creating instances of the stats object and passing it to every room. Logically, does it make sense in order for somebody to build a room that you need to pass some statistics? We can make it work. We saw it work. It doesn't really make sense.
Unless you're making multiple caves.
Not unless we're making multiple caves. So what State Farm wants to do is he wants to make all of these static. So we would not even have a constructor. Numrooms would start off as 0. we would have a static method called addRoom, and we'd have a static method called getNumRooms. Class method or instance method? What kind of method is this guy? I would have expected an answer by now. It's class method. How do you know? Static. Okay. So how do we call class methods? Again, I'd expect an answer by now. Stop just copying what I wrote and think about this. How do you call class methods? How would I call that method right there?
Stats instead of this.
Well, I would call this method by saying stats.addRoom. Okay? By making this static, this guy is no longer accurate. Why? This whole thing is inside of a static context, and this does not exist in a static context. That makes sense? We could say stats.numRooms++. That exists in a static context. Similarly, we can say stats.numRooms to return it. That exists in a static context. Now what we can do is we can say room no longer takes a stats object as a parameter. So we would no longer pass a stats object. In cave, we would no longer pass our stats object. Similarly, we no longer create an instance of our stats object. Instead, we now have a global object that all rooms have access to, called stats. So every single time a room is created, we can say stats.addRoom, calling that class method. Does that make sense? And every single time we call stats.addRoom, what happens? Our initial one-time variable called numRooms, this guy only exists once, gets incremented by 1. At the end of cave, we can print out stats.getNumRooms. So we're kind of, stats is kind of a global scorekeeper, if you will. We're using this guy to keep track of all of our rooms that are created. So we'll have the exact same output that we had before, but the way we're getting to it is through a static context. Make sense? Okay. Now, might we also be interested in the treasure? How many treasures the entire cave had in it? So we'll create a private static int numTreasure. And numTreasure will start off as 0. We'll create a method, public static void add treasure. And this guy will say stats.numTreasure++. And then we'll also create a public static int get numTreasure. And this guy will return stats.numTreasure. So now every single time we create a treasure, we want to output numTreasure. Well, we want to increment numTreasure, and at the end we want to output number of treasure. So inside room, where we're creating our treasure, right here is where we create the treasure, right? So immediately following that, we can ask the question, if this dot has Bitcoin, that is, if a treasure now exists, we're going to say stats dot add treasure. That makes sense? We randomly generated whether or not we have a treasure. Since we do, increment the treasure. The end of our cave. We'll also, well, here, let's just label these. Number of rooms is that. Number of Bitcoins is that. So those two statistics should have been built up by using our static context stats within our room constructor. We run this now, we should see that the number of treasures is roughly half the number of rooms. Oh, look at that, 115 rooms with 54 treasures. I'm trying to think why we're out of stack space. We really shouldn't be. I should be able to create up to 4 rooms. No problem. Or up to 3 rooms.
Just the further you get in the stack, the less likely it is to end. It's going to make more.
Well, right, but it just surprises me that we're running out of. It really surprises me a lot. Let me check something here real quick. Oh, we did it based on 3 there too. Okay. 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 So we have our rooms being created now. We probably want a room to be able to display itself. So we're going to teach a room how to display itself. Well, we'll probably start off by saying system.out.println. Let's put some asterisks in here. This dot name. Then, let's say obvious, we'll do a print. Obvious exits. So obvious exits are going to be based on the number of exits we have. For int I is equal to 0, I is less than this dot, the exits dot size, I plus plus, and we'll say system.out.print I concatenated with a space. So if there's 3 exits, we'll see 0, 1, 2. If there's 2 exits, we'll see 0, 1. If there's 1 exit, we'll see 0. If there's no exits, we'll see none. Well, we probably want to see none. So we'll ask the question, if this dot the exits dot size is equal to 0, system dot out dot println none. So if we have no exits, we'll actually say the word none. Otherwise, we'll run our little loop here. That'll print out either 0, 0, 1, or 0, 1, 2 for our obvious exits. We're going to, instead of saying north, south, east, west, we're going to say that we have 3 exits. One of the exits is in the direction 0. Another one's in the direction 1. Another one's in the direction 2. Make sense? Okay. So that's how a room displays itself. Inside cave, after a cave is created, why don't we say this dot, the entrance dot display. We'll have that first room display itself. Total number of rooms is 24. Total number of treasures is 13. We're in a room. Obvious exits, 0. We have a single exit. If we had no exits, it would say none. That makes sense? Now, how would I enter that room? I want to walk through my cave. Oh, we forgot something in our display. Whether or not there's treasure. So after we print out obvious exits, we want to say system.out.print treasure. Actually, we could probably just do this as a quick little if statement. If this dot has Bitcoin, if that's true, we'll do a system.out.println treasure a Bitcoin. Else, system.out.println treasure none. So that's whether or not we have a treasure. So run this again. Oh, hold on, we need to, after this for loop, we have to kick it down a line. So just do a println to press enter after we finish filling in our exits, 0, 1, 2. So here's our first room. Obvious exit 0. Oh, we have a Bitcoin in this room. Run it a couple more times. Here, there's no treasure in this one and no exits. That sucked. Here we got 2 exits in this room, but no treasure. But there are 28 treasures somewhere in the cave, just not in this first room. So now we need to be able to traverse our cave. If I'm in this first room and I want to get into another room, I need to either go through the exit that is door 0 or the exit that is door 1. And those doors lead somewhere, right? They lead to another room. How do I go into another room? So this is our code so far. How would we traverse this cave? We want to traverse it from our perspective. We're the user, right? The human being. So we're going to have to ask the user for some input. That is, what door do you want to take? Do you want to take 0 or 1 or 2 if that exists? So on and so forth. So let's say that I'm in this room and it happened to ask me, what door do you want to take? Okay. Well, actually, in fact, let's just write that real quick. So inside of room, we're going to create a method, private, just have it be void for right now, prompt. We're going to create a scanner. System.out.print. What would you like to do? Question mark. Then we'll say, we'll just assume we put in correct input for right now. We'll say int answer is equal to input dot next int. Actually, maybe we do this. Why don't we make it a string? String answer is equal to input dot next line. That'll read in the string. And for right now, we'll just spit answer back out to the screen. Okay, so prompting creates a brand new scanner for reading stuff in from the keyboard. It gives them a prompt, what would you like to do? Then it reads in whatever they type after they hit enter, and then it just spits it back out to the screen. That's what prompt does right now. At the end of display, after we show them all the stuff regarding this room, we'll then prompt them. Make sense?
Would you want to put that in an if statement because if they don't have exits, then it's like.
You could, but for right now, we're not going to do it because you guys haven't told me how we're going to move between rooms yet. I'm just giving you a little something to bite onto here. A hint. So, obvious exits to 0. So the only thing we really could type in here is 0 for right now. I'll go ahead and type it. I'll press enter. It would have read it in and just spits it back out. I need to now react to that. If I typed in 0, I need to move into the room at exit 0. What does it mean to move into the room? How would we accomplish this? Well, what did it mean for me to move into the cave entrance? That's where I'm in right now, right? How did I become aware that I was in the room cave entrance? It displayed itself to me, right? So from our perspective, the room we're in is the room that last displayed itself, right? So if I enter in 0 here, I would want then for the exit at bucket 0 in the exits to display itself to me. That means I'm in that room, correct? And then that room can then prompt me, what would you like to do next? To help us better understand this, I'm going to change the name of this method. Instead of calling it display, I'm going to call this method enter. That was a good pop. Do you even know what's actually being adjusted in your back? Because when you twist like that, probably the thing that's moving is called your sacral iliad joint. SI joint. Very interesting. You just learned something. Chiropractic. You can go become a doctor of chiropractic now, specializing in adjusting the SI joint. What's up?
Put it on a strip. Put the person on
Oh yeah, it's so good, right? You pull all their vertebrae apart, and then okay, you ready for this? Love that. Okay, so we're going to rename this method enter. Go ahead.
It'd be better to refactor it so wherever you told it to display it.
Yeah, we're going to call it in 2 places. So you're right, if we had it in more places. But I renamed it enter there, and then I'll rename it enter here. So what do we do after we create our cave? We enter the entrance. That make sense? Okay. Now, when we prompt, we're getting our answer, correct? And our answer is going to be, well, in this case, our only answer was 0, but it's going to be 0, 1, or 2. So let's just assume that we entered something reasonable in, so we had just entered 0. So I have 0 right here stored in answer. As a result of that, I'd like to enter the room at position 0 in the exits. That's what I want to do, correct? How do I do that? I'm inside the prompt method here. Who knows about the exits? It's a trick question. I'm in the prompt method of who? Room. Who knows about exits? The room knows about exits. So do I have access to the exits inside of prompt? Sure. This is an instance method of the room class. Therefore, he has access to all of the things within the instance context, including the instance field, the exits. So for now, let's just assume that answer is a true number. Okay? We're not going to do any error checking for the time being. So what are we going to do? We're going to say this dot, the exits dot, get integer dot parseInt answer. That will give us the integer version of the string that they typed in. So this whole thing is going to boil down to a room object, correct? That's going to be a room object. What am I going to do with that room object? I'm going to enter that room. What's that going to do? It's going to show me all the crap having to do with that room. Okay? So we'll go ahead and run this. So total number of rooms is 4. Total number of bitcoins is 2. I'm currently in a room. I have 1 exit available to me. There's no treasure in here. So my only option is to go hit 0. I'm going to hit 0, press enter. It's going to then go and get the room from the exits at bucket 0 and tell me to go into that room. So as soon as I hit enter, it's going to display the details about that room, the room through the door labeled 0. So now I'm in that room. This guy also has a room 0, no treasure, so I'll put 0 again. This guy had a Bitcoin. He had a Bitcoin in it, so you can tell we're going into different rooms, right? So this guy has a Bitcoin, also only 1 exit. This guy also has a Bitcoin, but we're out of exits. So we've hit the end of the cave, taken all the paths that we took. We happen to, in this case, visit every single room in the cave just because of the nature of this particular cave. But we just traversed our cave. Right? Okay? Now, as we traverse the cave, we probably want to collect treasures. Correct? We see a Bitcoin, we want to grab it. That's what they do in all the Indiana Jones movies, right? They go into one of the dangerous caves, and Indy never touches anything but the little weasels he brings with him. They're always grabbing at the treasures, and what happens to them? They die. Every one of them dies. They get crushed by some boulder, the booby trap right? Every one of them. So we want to obviously grab the Bitcoin. This isn't Indiana Jones. This is Cave Crawler Pro. Available tomorrow on the App Store for $9.99. We're gonna have to make all of our profit up front on this one, guys. Everything needs. Everything. That would be actually interesting. Is have this be part of Bitcoin mining.
No, what you do is you call it Bitcoin miner, and you charge people to get it, and they think that they'll start playing games like, oh, I've got Bitcoins. Oh my God. Bitcoins. And then they're like,
Great
"Oh, my
idea.
Bitcoins."
Granted, you give them a whole explanation of what Bitcoin mining is. It's like you never actually say that you're actually mining Bitcoins, but you just allude to it all over the
No,
place.
you just give them one of the lower currencies that are worth like 10 cents a coin.
No, you don't even do that.
You can give them
Yeah,
currency.
No,
yeah.
it's real.
They think that by traversing these caves and finding Bitcoins, they are endeavoring in the Bitcoin mining industry, right? You almost could make it work that way, though. If somebody were to build a Bitcoin mining warehouse, let's say, and they sold an app like this, and what they did is they actually gave these people produced the dollars that produce the money to, well, these guys, by buying the app, they produce the dollars that is used to buy the hardware and pay the power bills and all this stuff to mine Bitcoins, and you can give them a chunk of what was mined. Well, it was just interesting, right? But I'm totally with you, Amish. Why are you sitting there?
Because my computer dies when it's not plugged in.
Oh, I see.
Now look right there.
So it's-
It's all the way to
So, yeah, it's a great idea because that's the hot word right now. So people searching there, Bitcoin cave miner. What if you could be part of the Bitcoin mining industry? Simply traverse our caves. Every level you beat, you've earned points towards mining your bit, and just show them this value, just some astronomical, like this, some fraction. You set the threshold. They don't get paid out till they've earned an entire Bitcoin. So every single time they're going through here, they're going to get tired of the game, probably before they even mine one Bitcoin. Because the Bitcoin mining software, they're mining, it might be 160 million hashes a second or something like that. And doing that 24 hours a day would take you like 7,000 days to mine one Bitcoin. That's 170 million hashes per second. These guys are walking through a cave by hand. There's a real low risk they're going to ever get a Bitcoin out of this. But I like the way you think.
If they do, they can cash in and get the Bitcoin at double the dollar amount worth per Bitcoin.
Well, they're never going to get a Bitcoin. But yeah, we can advertise as that. The greatest payout of all Bitcoin sites. We pay you 2x Bitcoin current market value. Why 2x? Why not say it 10x?
Bitcoin right now, $504.
They went up.
Yeah, it's up today.
Yeah, it was like
It's up like $40
Yeah,
today.
it was like $440 the last time.
Yeah.
I checked.
Man, it's climbing.
Probably drop another $600.
Yeah, like the pool I'm part of is called Slush. That I'm experimenting with this Bitcoin mining thing. Yesterday I mined I think like 0.00000016 Bitcoins. But that was an official payout. It's in my wallet. So I can
That's what.
I'm well on, no, not even 50 cents. No, it's not even close to 50 cents. It's like 2 cents.
It's 5 cents. No, that'd probably be like 6 cents.
Max.
Not even
I'm well on my way to buying a pack of gum. Maybe end of the month. End of the month, I got a pack of gum out of this. But then you got to figure the electricity I've spent, so I maybe have to buy you a pack of gum. All right. So now we're traversing this cave. Now we want to be able to collect our treasures as we go through the cave, correct? So, for your homework, this should be a pretty easy assignment. I'm going to give you the current state of our code. And I want you to add the functionality to our program so that at the end, when they finally hit a dead end, they can press Q to quit. And it shows them the number of treasures they've collected along the way. Does that make sense? They don't even have to, they can hit Q at any time. So every room has the option they can quit if they want. But when you get to a dead end, your only option is to quit. And when you quit, it should display the total number of treasures you've picked up. All right, so I'll go into my Dropbox here. This is called 300 Cave Crawler, right?
I don't feel like it's that epic. I'm sure what you do.
Okay, this is this class. And this is due on Thursday. So I'm putting this up right now. And I'll see everybody on Thursday.
No, just keep it.
He doesn't. He's exactly trying to read the camera.
This is my
You should just like send him your house.
Did your Xbox sell?
What's that?
I don't know if you have one.
It's not bad.
$8 so I'm sure someone else will work on it and get it done before it.
I mean, that's when it goes up a lot.
I'm not
It's not
sure.
Wait.
Yeah.
Tyler said. You got what? This one.
Oh, gotta get back into it.
I know that
suck.
yesterday he wanted to do as much as possible.
Well, it'll send when I have network. Oh, it's.
You should still just make it so that they give up that somehow you're calculating the actual Bitcoin. You're using everyone's like you get you pull from the stack,
Mm-hmm.
and then you take everyone playing the game, and then you somehow make it into the binary calculations for whether the transaction is valid or not.
Okay.
So you take everyone that's playing your game and you actually mine Bitcoins with them.
You'll probably be mining like 0.0007 millihashes per.
No, but the thing is that I've seen some people that don't use the most legal methods, but essentially they create programs that are just viruses that run on your computer and mine Bitcoins, and then they just
Distribute it.
them in mass.
Yep.
And it's just like ridiculous, and then they're mining like 3 Bitcoins a day.
Oh, really?
Yeah, it's crazy how much they actually
On
make.
somebody else's power bill.
Oh well, hundreds of thousands of people's power bills.
Yeah,
goes
right.
down. But yeah, I mean, it's possible to make decent money if you're not using your electricity.
Sure. Well, I think the cool thing is I ordered a USB one off Amazon. One of those ASIC things is a little USB device. No, it's a USB device you plug in, and instead of using your graphics card,
Oh, really?
it's like a specialized tool that's very, very, very good at cracking Bitcoins.
Oh.
So, for instance, if you have a really good graphics card, let's say, like, $800 graphics card,
Yeah.
it's going to probably do like 700 millihashes a second.
Yeah.
Like that's the best of the best.
Right.
Most really good ones are going to do 200 or 300 millihashes a second.
Sure.
This little USB thing is $22, can do like 2.2 gigahashes per second. But even gigahashes is low. I mean, that's not
you're
gonna.
still not even
You're not gonna make anything. But it's you're using a lot less power. Yeah, install one of them in every one of these computers.
Just like, we come in here on Thursday and everyone has just like a flash drive sticking out. What is Slippin doing now? I wonder.
Well, no, what you can do is put multiple flash drives in every one of them. So you could have each one of these machines doing like however many ports there are, like maybe 2 or 3 or 4.
You don't even need the mouse and the keyboard. You can just.
Well, you'll still need to. You still have to get the program, the mining program,
Something.
huh?
Just TeamViewer.
Oh yeah. You still have to put them on all of them, so it runs
Yeah.
it.
Yeah, you just install TeamViewer and then you rip
Yeah.
out every port, USB port.
Right, and then so you'd have each one of these machines here. We're still recording this. That's cool. You'd have every one of these machines. So let's say there's 4 USBs per machine. So this would be 8 giga hashes per machine. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 80 giga hashes just in this room.
It's pretty good.
Then you go down there. You probably have another.
You have like 20 max, I think.
Yeah. So now you have, let's say you have a total of 40 machines between all the rooms,
I think
each doing 8. So you're doing 320 giga hashes
It's pretty good.
in computer science.
Concordia is under investigation today for a massive Bitcoin mining operation.
Well, that's illegal.
A massive Bitcoin mine. Yeah, it's not illegal. You can mine Bitcoins.
The problem
There's
is that-
legal ways of mining Bitcoins, and then there's the virus thing that people are doing.
Yeah.
This is completely legit. You're buying the thing off Amazon.
The problem is that you have to find enough transactions to mine.
Well, that's why you get into one of the big pools.
Right. Last time I tried mining, like it took me like 30 seconds to find something to
Oh, really?
Yeah. But that was like 2 months ago, so I don't know. Yeah.
Yeah, I mean, I don't think it's a get-rich-quick scheme. I think it's a very interesting thing.
I think it was a get rich quick scheme before it just like shot
Mhm.
up. Like it went from 200 to like 1,000 in like
Mhm.
a week. And that was probably like, if you're playing with investment, if you're playing with like a couple $1,000